How do you check whether a number is divisible by another number? I need to test whether each number from 1 to 1000 is a multiple of 3 or a multiple of 5. I tried this code in Python 2.x. The idea is to try dividing the number and see if the result is an integer. However, I'm not getting the expected result. How do I test whether the number is an integer? In 2.x, division like this will produce an integer, discarding the remainder. See, how can I force division to be floating point? Division keeps rounding down to 0? For details. In 3.x, the division will produce a floating point value. The result is not an integer, even if it is a whole number, so the ice instance check will fail. See, why does integer division yield a float instead of another integer? For details. If you need the remainder from integer division rather than just testing for divisibility, see, find the division remainder of a number.
You do this using the modulus operator, %. Evaluates true if and only if n is an exact multiple of k. In elementary maths, this is known as the remainder from a division. In your current approach, you perform a division and the result will be either always an integer if you use integer division, or always a float if you use floating point division. It's just the wrong way to go about testing divisibility.
You can simply use %modulus operator to check divisibility. For example, n%2 equals 0 means n is exactly divisible by 2, and n%2 not equals 0 means n is not exactly divisible by 2.
You can use %operator to check divisibility of a given number. The code to check whether given no is divisible by 3 or 5 when no less than 1000 is given below.
I had the same approach, because I didn't understand how to use the module %operator. This means if you divide 6 by 3, you will not have a remainder. 3 is a factor of 6. Now you have to relate it to your given problem. This is saying, if my number, n, is divisible by 3 leaving a 0 remainder. Add your then, print, return, statement and continue your.
This code appears to do what you are asking for. Or something like. Or any number of things.
I'm